Hello, my amazing Algebra 1 students. Now we're back with part 2 of lesson 8, all about area. This is example 8.8, and this one really brings everything that we have studied so far together in this lesson. Okay, because what we have is they tell us that these two lines up here are parallel to each other. And so we have this little triangle shape down here on the end, and we have a half circle. So we're trying to find the area of this figure. So they tell us that this is rectangular here because they tell us that these are two lines that are parallel to each other. And so we can, knowing that these are parallel, we can draw these little squares here to realize that this is a rectangle. So we don't have this height given to us, but we do have that the circle here has a radius of 2. Since the circle has a radius of 2, won't this length here be 2, but won't also this length here be 2? So 2 plus 2 is 4, so this height is 4. So even though they didn't give it to us, we could figure it out. Since this line is 5 and this whole line is 7, we know that the 5 must match a 5 down here. So let's take our 7 and break it up into a 5 and a 2. So now we're all ready to figure out our area. So we have, let's start with our rectangle in the middle. Rectangle area is length times width, or 5 times 4. So this in here is going to be 20 square units. Okay. Then we look at our triangle, and our triangle is 1/2 base times height. Base is 2, height is 4, 1/2 of 8 is 4. So this area in here is 4. So we have 4 and a 20, and these are all square units, which I'll get to at the end. Then we have a half of a circle. So the area of a circle is pi r squared. But we're only looking at a half of a circle. So let's take this area and take the circle area and divide it in half. So now the radius is 2. So that means that this r squared will become a 4. But then we have the 4 divided by the 2 is going to be a 2. And so they're going to cancel and leave a 2 pi. So this area here is a 2 pi. Now we're going to multiply the 2 times 3.14 because an estimate is going to be more useful to us than an exact here. So 3.14 instead of the pi times the 2 is going to be 6.28 when we multiply. So this inside here is 6.28 square units. Okay, so now 20 plus 4 is 24, plus the 6, whole number 6, is going to be 30.28. So 30.28 square. Now let's go look at what our units are, and our units were in inches. So square inches. And remember, your book is often writing inches squared instead of square inches. They mean exactly the same thing. And there is your whole board for that example, which was example 8.8 on page 40. Okay, now we're talking about parallelograms and trapezoids and the areas of those two types of figures. What we have now here is a parallelogram, and I want to show you two different ways that you can think about a parallelogram so that you will never ever forget how to find the area. So when we're talking about a parallelogram, you can see this little arrow. It's like a part of an arrow. That is our symbol for parallel. And so this side is parallel, which means it's the same slant, and then this side is parallel to this side. So all of the sides are opposites, are parallel to each other. Ooh, excuse me. So now we have this figure. I want you to see that if we cut this triangle off to where we had a right angle here, And then we cut it off and we slid it over here. And we plugged it right there. Can you see, that didn't look very straight, did it? Can you see how we now have a rectangle? So if we slice off one of the little rectangles here, slice off that rectangle, move it over here, and slide it in there so that it's no longer here, can you see how we would have a rectangle? So the parallelogram is going to have the same area as the rectangle with the same base, here's the base, and height. So the area of a parallelogram is simply base times height. It's not the slant height, it is the vertical height. Okay, so the vertical height and the base multiplied together will give you the area of a parallelogram. So let's look at one more way to think about it. So here is a parallelogram. Okay, opposite sides are parallel. So this one looks like it needs to be just a little bit more slanted to match the other one. Opposite sides are parallel. So now let's think of it another way. Let's think of this as, I can do it either way, two triangles. So the parallelogram can be divided up into two triangles. Well, this triangle here would have a 1/2 base times height. Okay, and then this triangle here would have this base, 1/2 base times height. Can you see how both of the bases are the same length and both of the heights are the same length? Well, so it's 1/2 of something and 1/2 of the same thing. So we end up with a whole, and so the area is base times height again, just like we figured before. Isn't that cool? Two ways to think about it, one formula. Area is base times height when you're dealing with a parallelogram. Example 8.9 on page 40, we have a parallelogram which has 8, 8, 5, 5 for the sides of the parallelogram, but for our area we need base times height. So we need to know this straight distance down, which they also give us, is 4. So 8 is the base, 4 is the height. 8 times 4 is 32 square units. And this one they said the units are in centimeters. So that's going to be centimeters squared. And that is all there is to parallelograms. Okay, so here we're talking about trapezoids. And the trapezoid is the last example in the book. Now I'm going to do this trapezoid two ways. Your book illustrates that we can divide this trapezoid into two triangles. And then we can find the area of each triangle, add the two triangles together, and then give the area of the trapezoid as the sum of the two triangles. Okay, so that is the formula they're using, but you're going to find that it's equal to an easier formula to calculate, and we will do it both ways. So first of all, we're going to call this one area 1 and this one area 2, and our total area is going to be the sum of those two areas. But each one of these is just a triangle, and the area of the triangle is 1/2 base times height. Remember, when we have an obtuse triangle, we end up extending a drop height. So we'll let this one be our base of this triangle. Okay, and so that would be 9, and our height would be 4, which is over here on this side, because we need a straight drop height. And then we take half of that because it is a triangle. Remember, the area of a triangle is going to be 1/2 base times height. So when I'm looking at this triangle, I'm going to let this one be my, we will use 9 times the vertical height, 4. 9 times 4 is 36, and we're going to cut that in half. 36 divided by half is 18. So area 1 here is 18. 36, 9 times 4 is 36, times 1/2 is 18. So now we're going to look at the second portion. The second portion, we're going to use a base of 15. 15 times the height of 4 is going to be 60, and cut the 60 in half, and I get 30. So 30 plus 18 is going to be, let's put it up here, 30 plus 18 is 48. And so the area of the whole trapezoid is 48, doing it with the triangle method. Okay, so keep in mind we got a 48. So now I'm going to take the same problem, but we're going to use this formula. Okay, 1/2 base 1 plus base 2 times the height. So now these are my two bases. Notice in the first triangle, didn't I use this for a base? In the second triangle, I used this one for a base. So if I were going to look at this triangle, it was 1/2 9 times 4. And then I looked at this triangle, and it was 1/2 15 times 4. Now, if I took those and I did them and added them together, couldn't I factor out the 1/2 and the 4? And I'm going to get the same answer here when I use this formula. Here is my trapezoid redrawn. My bases are 9 and 15. So 9 and 15, when I add them together, will give me 24. So 24, I have 1/2 times 24 times the height, which was 1/2 24 times the height. Remember, the height was 4. So we have 1/2 of 24 is 12. 12 times 4 is 48. And guess what? Remember on the last one, we got 48 when we used the triangle method. We got 48 when we used the trapezoid formula. Now, your book has not yet introduced this, but they will. Okay, so that is the trapezoid area formula, and it is coming from the triangle method, because 1/2 the first base times the height is the first triangle, and 1/2 the second base times the height is the other triangle. So it is equivalent to the triangle method and is actually meaning the same thing. Here is practice A, and I'm going to find the area just by drawing a little chop line there. I'm going to separate this figure that looks kind of like a, I don't know, a big axe or something. I'm going to separate it into a rectangle and a rectangle. So this little rectangle is 6 long and 2 wide for an area of 12 square units. This one is 9 by 5 for an area of 45 square units, and 45 plus 12 is going to be 57 square, and the units in that problem are inches. So this one was practice A in your book. Okay, so this one is a figure that they tell us the corners that look square are square. So I put little boxes in them so we know that they are right. And then I'm going to do my little choppy thing and make a triangle and a rectangle. The rectangle is simply length times width, which is going to be 7 times 4 or 28 square units. The triangle is going to be 1/2 base times height. Now we have to do a little bit of math here. Since this is 10 and this underneath this rectangle must be 7, 7 plus 3 gives us the 10. So we took the original 10 and split it up into 7 and 3 to match the top part of the rectangle. And now, since this height is 4, this height here is also 4, And remember, the area of a triangle is 1/2 base times height. 3 times 4 is 12, divided by 2 is 6. So my overall area is 28 plus 6, or 34 square units. And they tell us that that one is in feet. So we will put that one in feet squared. Square feet, feet squared means the same thing. That is example B. Oh, Mrs. A has not been telling you.
Pause your video and do your practice on your own.
Now, hopefully, you will look at this one, and the radius is 5 centimeters, and the area of the circle is what we don't know. Remember, area is pi r squared. So now we've got to take the r and plug it in here, and the r is 5. So make sure you pause your video, go off and do that very quickly, and then come back and see the rest of the answer. Go ahead, do it. Pause, pause. So now here we are with our r squared is going to be 25 because we're going to plug in the 5 and square it. So we get 25 pi is our area. And in your book, it tells you that you will always use 3.14 unless told to use something else. So we're going to have 3.14 times 25. And 4 times 5 is 20. Carry the 2. 5 plus 2 is 7. 3 times 5 is 15. And then this 3.14 times 2 is 628. So 628. I don't even have to multiply that. I've done it so many times. And now we are going to add that up. 0, 15. 5 plus 3 is 8, 7, and then 2 decimal places. So 78.50. And that makes sense because remember, pi is a little bit over 3, and 25 times 3 would have been 75. So 78.50 is a very reasonable answer. So the area, since this was in centimeters, the area is going to be in centimeters squared. 78 and 50 hundredths centimeters squared. Here is your last example. Everything that looks like it should be square is square. So we can put a little square in here and a little square in here and a little square. I guess that's all the squares we can put. But remember, we're going to start this out by doing a little drop here. And then we can put a square here and here. So I'm going to leave you there and tell you
to pause your video.
Okay, now that you're back, we're going to adjust this 7. Take off the 7. Since we have a 4 up there, don't we need a 4 and a 3? So we're going to split up the 7 that we had originally into a 4 and a 3. This is your practice D. So now, since we're not given the height, but we're given this little half circle here that has a radius of 2, which means that this part up here must be a 2, and this down here must also be a 2. So 2 and 2 is 4, so we do know the height. So now we have really, it should look like a square, but I made it too wide, didn't I? It's really a square. 4 times 4 is a square, so 4 times 4 is 16. And looks can be deceiving. And then over here we have a triangle, and the triangle is going to be 1/2 base times height, or 1/2 12 will be 6. So the area in there is going to be 6 square units, 16 square units, and then over here we have a little half circle. So we will have pi r squared divided by 2 because the circle is cut in half. The r is 2, so r squared will be 4, and 4 pi over 2 is 2 pi. And 2 pi, remember, is 6.28. We don't even have to do that. We can just learn it. So now let's add everything up. So 16 plus 6 is 22. And then we have 22 plus 6.28 is 28.50. 8.28. And they told us that that was in meters. So that's going to be meters squared. Okay, and there is our answer. That was our last practice. That was a very long section on area, but I hope you learned a lot. And this is Mrs. A, and may God bless your day.